Hello, everyone. First of all, thank you all for taking the time to join us today for the webinar on how to build intelligent web applications at Edge. My name is George John. I'm a product manager with Amazon Web Services in the Cloudfront Lambda at the Edge team. So today, I want to discuss with you how you can move some of the core logic that makes up an application that traditionally runs in a backend server, how those can be moved closer to the viewers with Amazon CloudFront and Lambda at the edge. This would enable you to have low latency, high performance website and web applications delivery. But first, we'll take a quick look at what serverless is and have a discussion on AWS Lambda. Then we will move to Lambda at the edge, which is really an extension of AWS Lambda, but has some key difference in capabilities and features, and we'll discuss those. Then I would like to share with you some examples, use cases of where you can actually leverage Lambda at the edge and CloudFront for moving various application logic from the backend origin servers closer to the viewers. And finally, want to make sure we leave time for Q&A to answer any questions you have for us. So if you are in the webinar, and if you already have questions, or if you have feedbacks, or if you have any kind of inputs that you could want to provide to us, please feel free to start typing in your questions in the Q&A window here. We have moderators who are actively looking at it. On the other hand, if you want to wait till the end to ask your questions, that's also an option for you. So let's get started. What is serverless? Serverless essentially enables you to run and build applications without the need to provision, configure, or manage servers. Now, with serverless, your application developers can focus on the core business logic and not really worry so much about the underlying runtimes and servers. Now, AWS pioneered in the space with AWS Lambda. So Lambda is a service that was launched in 2014, which essentially is a serverless compute offering from us. So with Lambda, you essentially provide the piece of code you want to run. You specify when the piece of code should be executed or run, and everything else is taken care of for you by the service. Another benefit of Lambda is a little bit more subtle. It is the automatic scaling or continuous scaling. So now with the serverless platform, there are no servers or hosts you have to manage, configure. All that is abstracted away from you. So some of the capacity questions that you had to answer before, so things like, hey, do I have enough VMs for the next 6 months? Or am I over-provisioned? Am I under-provisioned? All these are kind of taken care for you by the service itself. Lambda would automatically scale your function, your code, in response to the trigger and events you have set up. The next benefit here is not needing to pay for cold or idle servers. AWS Lambda charges you only for the compute time for which your functions executed in a millisecond granularity. And the last benefit here is the fact that the whole availability and fault tolerance of the distributed system like Lambda is taken care for you by the service itself. Let's dive a little bit deeper here. At the core of AWS Lambda service is the concept of Lambda function. So functions is the mechanism by which you provide the piece of code to the service. So today, various popular programming languages, some of them listed here, are supported. So you can provide your piece of code, and your Lambda functions can then pretty much do anything you want. So your functions can speak or interact with other services, other data stores, databases. It can reach out to endpoints, whether it's API endpoints or such. And you can load third-party libraries. You have a lot of options in terms of what your functions can do. Once you have provided your code by means of a function, the next step you have to do is configure an event source. So the event source is essentially the trigger or the mechanism by which your functions get executed. So it could be things like you have, let's say, Amazon S3 bucket, anytime object is put to the S3 bucket. Let's say you want to run a Lambda function. If that's a use case, you can configure the event source for your Lambda function to be S3 bucket. Another example would be a call to an API gateway. And let's say you want to have a Lambda function that gets triggered synchronously to process the request. Then you could set up API gateway as the endpoint to your function. Now, in a bit here, I'll cover the different event sources that is supported. There are 30 plus event sources, and this list keeps growing. There are three core concepts of a Lambda function. The first one is a handler. So handler is essentially the entry point to your code or your logic. So once the execution is in the handler, you can then call third-party libraries or your own or other functions and such. So handler is the main entry point that you define. And the next concept here is an event object. So event object is how data is passed into your handler or your function. So let's go back to the example I had before. So let's say you had set up Amazon S3 as the event source for your Lambda function. Then the event object would contain details about the S3 object that triggered your function. And the third concept here is a context object. So context object essentially is an interface for you to get access to the underlying environment, underlying configuration. So things like the request ID, the log group, the status of the execution, all that can be retrieved using a context object. And looking at the event sources that you can set up to trigger your Lambda functions, there are many. This is again not the full set, but this should give you a good idea about of the different sources that we support. So from a data store standpoint, you can set up your functions to be triggered by a change in the state to an S3 object, or somebody inserting a record in a DynamoDB table, or a change to a Kinesis stream. Then there are endpoints such as API gateway, IoT, etc. So these are more synchronous, so meaning that when a request arrives to the endpoint, and if you want a Lambda function, you can set up these endpoints. So if you have an Alexa-enabled device at host, it is most likely that the Alexa skill is being backed by a Lambda function. And today, our focus is really going to be on Cloudfront as event source. Now, Cloudfront is a CDN, a content delivery network service from AWS. When you set up your Lambda function to be triggered with Cloudfront as event source, that is what is Lambda at the edge. Let's take a quick look at what Cloudfront is. So Cloudfront is a content delivery network offering from AWS. It was launched in 2008. So it's one of the older services from AWS. So this November, it's going to be 10 years. And over the years, we have built in various capabilities, right? So when I typically speak with customers understand the benefit of using a CDN for static content which is pretty cacheable, which doesn't change. But we have built in various enhancements to the underlying Cloudfront service to even help you accelerate the delivery of dynamic content. It's highly secure. Security is a #1 priority. By virtue of being a Cloudfront customer, you get various features at no additional cost out of the box. So things like SSL end-to-end SSL connections end-to-end, being able to bring your own certificates at no additional cost with Amazon Certificate Manager, being able to set up the TLS protocol policies. And also, Cloudfront has integration with some of the AWS security services like AWS WAF, which is the Web Application Firewall, and AWS Shield, which is the managed DDoS protection service from AWS. Cloudfront is massively scalable. So if you look at the geographic locations where Cloudfront has presence today, we have altogether 136 POPs or points of presence. These are in addition to the AWS regions. So, and this, if you look at the list, it keeps growing. So year over year, last few years, we have been adding on around 50% new POPs every year. And this list would keep growing based on where feedback we're getting from customers and where we would like to expand to. And Cloudfront, it's a self-service, on-demand, pay-as-you-go pricing model that all AWS customers are familiar with. But Cloudfront also has a pricing construct where we could have private contracts with customers who are willing to make a commitment. So having discussed Cloudfront, let's get back to Lambda at the Edge again. So Lambda at the Edge, by virtue of being an extension of AWS Lambda, has all the benefits of Lambda, but a key additional capability is the global distribution. So what do I mean by that? So let's go to this, take a look at this picture here. So today, AWS Lambda at the Edge offers you the same experience for writing a function. So to write Lambda at the Edge function, you would select AWS Lambda as a service. And today there is a restriction that you have to be in North Virginia region. So US East 1 is a region you have to select. Then you go to AWS Lambda console, and then you write a function as you would write any other Lambda function. The key difference is when you select the event source. So when you select the event source as a Cloudfront, then it becomes a Lambda at the Edge function, and then there are some differences in how the rest of the processing happens. So what happens is, after you have edited your function, after you have tested it, and once you are ready to submit the function, when the event source is Cloudfront, Lambda at the Edge automatically, behind the scenes, replicate the function at multiple locations worldwide. Now, this is not the full set of all the locations we have. This is just more for a representation purposes. So your Lambda at the Edge functions are replicated to multiple locations worldwide. Now, what is the benefit of that? Like, as a customer, what do you get out of that? So let's take a look at that. Let's go with the scenario that you have a simple web application, and any web application typically would have some sort of compute, some sort of database, and the storage. So compute could be a virtual machine like EC2 instances. It could be containers. It could be Lambda functions. Database could be SQL or NoSQL, the various options AWS has to offer. And storage could be, again, S3, block store, and the other options that are available to you. And in this scenario, let's assume that your application is running in an origin in Virginia, in North Virginia, which is US East 1 AWS region. Now, if you have a couple of users who are trying to access your web application, it should be just fine. They can just directly go to your origin, and the experience they get might work well. But as soon as you have more and more users trying to access the origin, especially when they are coming from distant parts of the world, the performance, the page load times the users are going to see is going to really vary, right? But as a web application owner, you want to make sure all your users, irrespective of where they are, get the same high user experience. Now, one obvious thing you can do is introduce a CDN like Cloudfront. So what Cloudfront would enable you to do is move some of the storage or some of the data that is part of the application closer to your users. So now, let's say you had previously a user in Australia. To fulfill the request of that user, the request had to travel all the way back to the origin in US East Coast to be fulfilled. Now, by the limitations of how fast data can be transmitted over the internet, the performance they see is going to be quite different from a user who's closer to the origin. But with Cloudfront, by moving your data closer to the location, the same user, when he tries to access the content, the request can be fulfilled from a location, from one of our locations in Australia, as opposed to sending the request all the way back to the origin. So those users are now going to see much higher performance because the request is served from a POP that's closer to them. So now you are able to move. So here in this scenario, you moved your content or some of your data closer to the users. And what does Lambda at the Edge do? What Lambda at the Edge provides you is move the compute as well as closer to your users. So your data, some of your content, as well as some of your compute can now move closer to the users in a serverless fashion. So let's again go back to the user we have in Australia. And let's say he has a request that requires some sort of logic or some customization or some code that had to run. So without Lambda at the Edge, the request had to travel all the way from Australia, all the way back to your origin in the US East Coast. But now with Lambda at the Edge, that logic that previously was running in the origin can be moved to a location closer to them in Australia so that the request can be fulfilled much sooner, much faster. The experience the user is going to be see from how soon the page can be loaded and what the latency is going to be really good. Let's dive a little bit more into Lambda at the edge. So I mentioned before that Lambda is an event-driven compute model, meaning you define an event or a trigger that is going to call your function. In the case of Lambda at the edge, the event source is Cloudfront, but there are 4 points in the Cloudfront request response flow where you can call your Lambda functions. Before we get into that, let me just set the stage, just walk you through the picture here. Now, on the left side, you have the viewer, or the end user who's trying to access the content that you're serving through Cloudfront. Now, this is a very simple diagram. You have one user, but in real-world scenario, you're going to have hundreds of thousands of users who are going to be trying to access your content from different parts of the world. And on the right side, you have the origin. So the origin can be elastic load balancer. It could be EC2 instances. It could be an S3 bucket, or it could be even your own web servers that are running in your data center or colo. Cloudfront is agnostic to where the origin resides. And in the middle, you have the Cloudfront location, right? This is just showing one. There are many locations that Cloudfront has today. So how Cloudfront's routing works is that when you are distributing content through Cloudfront, and when the viewer tries to access the content, Cloudfront will route the viewer's request to a Cloudfront location that's closest to the viewer from a latency standpoint. So Cloudfront is constantly getting data about in real-time internal measurements, and based on that, it is routing the request to the most appropriate location. So let's look at the flow of request and response. So once the viewer's request has landed in the Cloudfront location, which is going to be the closest from a latency standpoint, there could be 2 things that can happen. The first scenario is a cache hit. So in cache hit, what happens is that the request, the data which the viewer is trying to access is already available in the cache. So the request is kind of fulfilled directly at the location, and the request doesn't have to travel back to the origin. So that's a cache hit. And the other scenario is a cache miss. So in cache miss, what happens is the viewer tries to access the content, but the content is not available in the Cloudfront cache. So in that scenario, Cloudfront would fetch the content automatically from the backend origin, the origin you have specified, and it would cache the content and serve the viewer. So that subsequent requests for the same object landing in that location would be a cache hit and would be served from the cache. So this is the request response flow without any Lambda in the mix. So let's say you have use case where you want to customize the request or the response that's served. And there are 4 events that where you can insert your function or your code. The first one is called a viewer request. So viewer request is executed right before a cache lookup is done. So if you have use cases or scenarios that needs to happen before the cache lookup, then you would leverage viewer request. The second event point is the origin request. Note that origin request gets triggered only in the case of a cache miss. So if the data is already in the cache, and if Cloudfront can fetch that, then your origin request would not be triggered. The third point is origin response. This is in the response path. So once Cloudfront fetches the response from the origin, and before it is cached, if you want to do an action or or run some sort of customization, you would leverage the origin response. And the fourth point here is viewer response. Note that viewer response happens after the cache, so any change, any customization, or any changes to the object you make is not cached, but it is reflected to the end viewer when he or she gets the object. So first, let's focus on the viewer request. So like I mentioned before, it happens on every request. It happens before the cache lookup. A new feature that we launched recently is access to HTTP put and post request body in the function. So all the 4 events that is supported by Lambda at the edge gives you access to the HTTP properties like the URIs, the query strings, the cookies, and the headers. And you can also modify, change, delete. But on the request path at the viewer request event and the origin request event, which we're going to talk about soon, both support an additional has an additional capability, meaning that in the Lambda functions you also have access to the actual body, the request body. All 4 event points supports making network calls to any HTTP endpoint, whether it's on AWS or outside. So your function, you can write a function to make a call to any HTTP endpoint. And the timeouts are slightly different, depending on whether it's a viewer-facing event or an origin-facing. Viewer-facing has 5-second timeouts. If you generate a response, so Lambda at the edge allows you or gives you the capability to generate a full HTTP response directly in your Lambda functions without the need to going back to the origin. So if you have a use case where you generate the response, then the response will not be cached because viewer request gets triggered even before a cache lookup is done. And the functions you define in the viewer request can have up to 128 megabytes in memory. Let's take a look at some of the use cases or some examples where if you didn't have Lambda at the edge, you had to run this in the backend origin. And with Lambda at the edge, you can now move these functionalities from the backend origin to closer to your viewers at the edge in a serverless fashion. The first one is Stateless Auth. So let's assume that you are using JWT token to pass in some sort of credential information, and you want to make sure even before you do any sort of cache lookup, you want to either allow or deny the request. So what you can do to achieve this use case is define a viewer request Lambda function. Now, viewer request, like I mentioned before, gets triggered even before the Cloudfront cache lookup is done. So your function is going to use the public key that you have to provide to decrypt the content in the JWT token, and then it can make a decision. Should I allow or should I deny this request? So if you allow the request, meaning that the request is going to continue in its journey, so if the data is in the cache, it's going to be a cache hit. If not, it's going to go back to the appropriate backend origin and fetch the content. On the other hand, if it is a cache miss, then what happens is you have the ability to generate a response directly, saying, hey, access denied, or redirect to a login page, whatever action you want to take. And the good thing about this is that now the request is not even traveling back to the origin. You're kind of handling the request at the edge directly with Lambda at the edge, and kind of helps offload the work and reduce the load on the backend origin. We have a couple of blog posts that discuss or talks more about this concept. These blog posts have some code samples, walks you through some screenshots of how you can set it up. I know it's not that easy to read the link here, but we would be sharing the slide deck as well as a recording to all the attendees after the session, and this is also going to be on YouTube. So you will have access to the link if you would like to learn more about this use case. The other use case that you can do with viewer request is stateful authentication. Now, your application might be built in such a way that it's not stateless, or there might be other reasons where you need to make a call to our external service that has a state or has information about whether the request should be allowed or not. Now, this is possible because of the capability of Lambda at the edge that allows you to make a network call. Essentially, in this case, your viewer request function, you could have a piece of code that can make a call to an entitlement service which is external to the Lambda at the edge, which then makes a decision of whether it should allow this request or not. So you could provide in all the properties of the request, including the headers, the cookies, query strings, to the entitlement service, and the entitlement service can look at the right attribute and then make a decision. And it would then let you know whether the user is allowed or not. And then your Lambda function can either allow the request to continue to fetch the content from the origin, or you could directly generate a response without even going back to the origin saying, hey, this user has been restricted or access is denied, or you could issue a HTTP redirect asking the user to log in. Another use case is redirections or HTTP redirects. So let's say you have a user who's trying to access the content, And let's assume that there is some cookie which contains information about the user session. The cookie could either be present with an expired value or with a valid value. So you could define a viewer request function which would inspect the cookie. If the cookie is valid, would allow the request to just continue in its journey. If the cookie is invalid or if cookie is not present, you could generate a response asking the user to log in or even deny the request. So here is a quick example of how the code would look like. Now, like I mentioned, there is a handler, which is the entry point to your Lambda function. Here, I'm not showing how the cookie validation is done, but that is something you can define based on your requirements. And here, the response block gives you an idea about how you can actually generate a HTTP response. So here, your Lambda function is directly creating a response with a status code of 302, which is a redirect to this particular login page. And Lambda at the edge function would send the response directly back to the viewer. So the logic which would have had to be run in the origin if you didn't have Lambda at the edge can now be offloaded to Lambda. One thing I forgot to call out earlier is that Lambda at the Edge was launched in GA middle of last year, so it's a relatively new service. We launched with the support for Node.js as the programming environment. We do not support the other languages which Lambda supports today. So very interested in getting your feedback. If you think you have use cases for us supporting other languages, please do provide that to us in the Q&A window. The next event I want to talk to you is on origin request. So origin request happens just before the request is sent to the origin. A key thing to note here is that origin request gets triggered only in the cache miss scenario. External network calls are supported in the same fashion as viewer request, but a key difference here is that the timeouts are much larger. You have 30-second timeouts. You have access to the put and post request body in addition to the other HTTP attributes like query strings, headers, cookies. Functions can be much larger in the origin request event. So we support functions to have as much memory as what AWS Lambda can support today. So it's your function, a single function could have up to 3 gigs of memory. Let's take a look at an example. The first one is template rendering. So this again falls under this use case is enabled because Lambda at the edge allows you to generate response at the edge. So let's say you have some sort of template, a mustache template that needs to be populated with some sort of JSON data, which could be residing in a database like DynamoDB. So essentially, you want to put these two data together to kind of fulfill the particular user's request. Let's see how you can do that. So here, what you could do is you can set up Cloudfront distribution with a cache behavior. So for those of you who are new to Cloudfront, cache behavior is essentially a mapping of URL path pattern to an origin. So you could define a cache behavior saying that, hey, if the URL path that the user entered matches /blog, then invoke this Lambda at the edge function. So you could have an origin request event function which gets triggered when the path matches /blog. And what this function would do is it makes network calls to multiple endpoints. So you could go to an S3 bucket, it can fetch the template. It can make another call to DynamoDB to catch the JSON object and put these together to create the response, which is then served back to the viewer. So you could have the rendered template cached and then serve the response back to the viewer. One thing you would have noticed here is that there is no origin. You don't need to set up web servers. Your Lambda at the edge function is kind of building the full response and serving the end user's requests. So the whole management of the backend web server, scaling it, all that is kind of abstracted away from you, and you are able to not only do it in a serverless fashion with Lambda at the edge, but you're also doing it from locations closer to the viewer. So the performance the end viewers see for your website is going to be much better. Just in terms of how the code for that would look like, you could have a Lambda function where you define connections to fetch content from S3 bucket. You could build clients to DynamoDB. And then here, if you look at the response element here, this is how you would generate a response. And here you would notice the status code is 200 because it's a HTTP success. You can set up headers. So here you're setting up some cache control headers to cache the content. And you could make multiple network calls to a DynamoDB table to fetch the JSON, and then the S3 to get the template, put all these together, and then serve the response back to the viewer. Another use case I want to share with you is rewriting URLs. So a popular example here is map tiles. So there's some well-defined format on how a map tile should look like. But in the backend, you could be using any origin or multiple origins for various different reasons you have. Right. For example, if you are using S3 for map tiles to get better read-write performance out of your S3 buckets and to leverage more partitions, it is typically a best practice to insert some sort of randomness into the URL. Or there could be even other reasons why you want to do a SHA-256 mapping of your URL. But the URL which is actually exposed to your end users or end app should be the format you want. So here in this example on the top, that is the URL you want to expose to your end viewers. And the URL at the bottom is actually how the data is kind of mapped in S3. And you can use the origin request to do a URL rewrite. So Lambda at the edge origin request would translate the URL from the user-friendly version to the backend origin-specific version. And the caching of the content is done with the user-specified URL. So the next time somebody tries to fetch the same map tile, it is going to be a cache hit, and the cache content can be served back to the viewer. Another bucket of use cases is on dynamic origin selection. So this is pretty powerful. This essentially gives you the ability to route your request to any origin in the backend dynamically in line with the request. For example, a use case here would be you have multiple origins. So you could have origins in different AWS S3 regions, so different S3 buckets in different regions. And you might want to send the request to the S3 region that's closest to the viewer from a latency standpoint, or you might want to load balances across regions. Another example is doing things like controlled deployments, or A/B testing or blue-green deployments. We'll take a look at an example shortly here. Or migrating between origins, so maybe you're migrating from your on-premise to the cloud, and you want to have certain objects being served from your on-premise data center, and you probably want to serve a few objects served from the cloud, and then so you can use the dynamic origin selection to route the request to the appropriate origin. And the last one here is the search engine optimization. So again, I have an example on that, and we'll take a look at that in a bit here. There's a blog in the that's being mentioned here. A quick note here: all blogs from Cloudfront and Lambda at the edge comes in AWS blog under the networking and content delivery channel. So if you Google AWS space blogs space networking and content delivery, you should have access to all the blogs that I am referring today, as well as all Lambda at the edge and Cloudfront blogs. So this is an example of A/B testing. So let's say you have two origins in the backend, and you're kind of testing out a new feature, and the new feature has been rolled out to origin B, and origin A is the current version. So you wanna, when a request comes in, you wanna send the users to the appropriate origin A or origin B. Let's say here you're using a cookie to make sure that during the session the user sees the same experience or gets the same experience. So you wanna make sure you send the user during an active session to the same origin in the backend. To achieve this, you could have an origin request function which gets triggered. It would inspect the cookie. If there is no cookie present, you can, based on whatever logic you have, you can decide to serve A or B variant. But if the cookie is already present, you can look at the cookie value to get an indication of which origin to send the request to, and then update your request properties so that the request is sent to the appropriate origin. A quick look at what the code here would look like. So here, what you're doing is you're essentially updating a property in request object, request.origin, with the value you want. So if you want to send it to a new origin, you would use the request, update the request .origin appropriately. And you will also need to insert a host header with the new origin details. Another example is search engine optimization. So let's say you have a web application and you want to serve different kind of version of your web application depending on the end user. So if it's a regular real user, you would send the user to your backend web service. If it's a good bot like a search engine crawler, you probably want to send the request to a pre-rendered, a pre-optimized, crawler-friendly version of your app. And if it's a bad bot, you don't even want to send the traffic to your backend origin. You don't want to create unnecessary load on the origin. Instead, you want to just generate a response directly using Lambda at the edge and fulfill that request. So what you could do is you could have an origin request function. In the origin request function, you have access to the user agent field. You can look at the user agent field, and depending on whether it's a good, bad, or good or bad bot or a real user, you can dynamically route the request to the appropriate backend origin. And in this scenario, if it's a bad bot, you're not even sending it to the backend origin. You are generating a response directly and doing an access denied response back to the bad bot. Another bucket of use cases on redirection. What redirection enables you to do is, you are able to, taking a step back, you are able to do redirection because of Lambda at the edge's capability to do HTTP response generation. So let's say a request comes in, you look at the Cloudfront viewer country, which is a header that Cloudfront exposes, that gives you an idea about the country from which the viewer is coming in from. So you could look at that header, you could look at the accept language, and then issue a redirect so that you are redirecting the user to a more country-specific version of your website. Let's take a look at origin response. So origin response gets triggered in the response path before the caching is done. So it's executed again on cache miss. It supports network call with 30 seconds timeout. Any changes or any updates you make to the object in the origin response would be cached. Your origin response functions gets triggered not only when you get a success from the origin, but also when there is a 4xx or 5xx error response. So if there is some sort of custom logic that you want to run when you get an error response from the origin, maybe try another origin, or maybe serve HTTP 200 with a very specific image or specific message. You can do things like that with origin response event. And functions can have up to 3 gigs of memory. A popular example here in this bucket is dynamic image manipulation. So let's say, depending on the end user's device, whether the user is coming in from a mobile phone or from a desktop, let's say you want to serve an appropriately sized image. So if it's a desktop, you're going to give full resolution image. If the user is coming in from a mobile phone, you want to serve a cropped image. You can do this on the fly dynamically using Lambda at the edge. So essentially what happens is when the user comes in, there might be indication about the user's device, either in user agent, or there could be something in the URI itself which gives an indication of what the resolution is ideal for the user. Cloudfront would try to see if that object with the right resolution is in the cache, in S3 bucket. If it is not, or if it is, a Lambda function would get triggered either way, and Lambda function can then check, hey, was the required object was found? So if the object was not found, your Lambda function could fetch the raw image, resize the image, save the image in S3, and then serve the resized image back to the viewer. Now we have this blog post which actually shares some code samples and has details on how you can build this using Cloudfront Lambda at the edge. If you're interested in learning more about this, I would definitely recommend taking a look at the link here. Another popular use case for the origin response is inserting security headers. We've heard from customers who say that, hey, origin cannot be touched, either because it's a very legacy application, they don't know who wrote the code, or maybe the person doesn't work with the company, or it's a different team, different from the team which is doing the content delivery. There could be various reasons you do not want to touch your origin. But you still have this compliance and security requirement where you want to make all these headers in the response. So how you could achieve that without touching your origin, without making any changes to the origin, is by leveraging Lambda at the edge and origin response function, where you can insert the headers you require. So since these headers are done at the origin response, the headers will also be cached in the object. So subsequent users, when they try to fetch the object return would have the necessary headers in it. Again, there's a blog on this if you're interested in actually looking at the code and how to set that up. I would recommend take a look at the link below. And the last event we have in the flow is the viewer response. Viewer response gets triggered for all requests, and it gets triggered in the response path after the caching is done. If you make any changes to the response at the viewer response, it would not be cached because it happens after the cache. You can make network calls, as well as the functions you define can have up to 128 megabytes in memory. A quick example or use case for this would be setting a cookie for a user which is very unique to the user. At the same time, you do not want that cookie to be part of the object. So the use case could be that you are serving the same object to all your users, but you want to have a very unique cookie. So if you do it at the origin response, which was the previous event, then the cookie would be cached along with the object. So now all the users would have the same cookie, which is not what you want. By doing it at the viewer response, the object is same for all objects served is same for all users, but the cookie that is set for the user is very unique to the user. So with that, we come to the Q&A section here. If you haven't, please feel free to type in any and all questions you have in the window here. We have moderators actively looking at. And we are also very interested in getting your feedback if there are features or capabilities, or if there are things we can improve, or if there are things we are doing good, please do let us know.